This is part 9 of the series Quadrilaterals, and in this part we're going to talk about kites. And a kite is a quadrilateral that has two pairs of consecutive congruent sides. So here you can see two pairs of consecutive congruent sides. And it has a couple of other properties that we're going to look at. The first property is that the diagonals of a kite are perpendicular, and that is in the kite diagonals theorem. If a quadrilateral is a kite, then the diagonals are perpendicular. And the other property is that kite opposite angles theorem states if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And you can see that these angles are between the consecutive congruent sides. So we're going to take a look at these two theorems, and we're going to generate some quick proofs of these. The first theorem we're going to work on is the kite opposite angles theorem, because it's the quickest and easiest theorem to prove. So our plan for the proof is going to be basically to create two triangles. We're going to draw in segment AC, an auxiliary segment, and then we're going to say that the top triangle, triangle ABC, is congruent to the bottom triangle by side, side, side. And then we can say that angle ABC is congruent to angle ADC by CPCTC. So a relatively trivial proof, but let's get started with it and see where it gets us. So we've written down our given, and now we're going to go ahead and put in our segment AC. So let's draw that in. And we're going to say that we can draw AC and through 2 points there is one line. Now we want to show that AC is congruent to itself. So AC is congruent to AC, and that's the reflexive property. Of segment congruence. And then finally we say triangle ABC is congruent to triangle ADC, and that's by side, side, side congruence. So here we have this side is congruent to itself. So we have side, 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 side. Now, our last statement is the statement we needed to prove. Angle ABC is congruent to angle ADC, CPCTC. Corresponding parts of congruent triangles are congruent. And there's our proof. Now we're going to go ahead and prove the kite diagonals theorem. This proof is very similar, but it starts out a little different. We have ABCD as a kite, and we're given that AC and BD are diagonals. The plan for this proof is almost the same. What we're going to do is first show that triangle ABC is congruent to triangle ADC, but then we're going to go to showing that ABC and DAC are congruent by CPCTC. Then we'll say that this segment is congruent to itself, and we'll probably have to put in a letter here. And then we can show that these two triangles are congruent. Once we have these two triangles congruent, we can show that this angle and that angle are congruent. And since they're linear pairs and a congruent linear pair, then we can use the congruent linear pairs theorem to state that AC is perpendicular to BD, and therefore that the diagonals are perpendicular. So that's what we're going to do here. Before we get started, let's go ahead and toss in a little label here. Let's make this E, and we'll begin. So first thing, AC is congruent to AC, and that's reflexive property. Reflexive property of segment congruence. Now we can say that triangle ABC is congruent to triangle ADC. And that's by side, side, side congruence. Now we want to show that this triangle is congruent to this triangle. So the first step there, let's go ahead and say AE is congruent to itself. And that's reflexive property again. And then we want to say that this angle is congruent to that angle. So angle B, A, E is congruent to angle D, A, E. And the reason is because this angle is part of the top big triangle and this angle is part of the bottom big triangle, so that's CPCTC. So now I have this angle congruent to this and this congruent to itself. So now these two triangles are congruent by side angle side. So triangle, let's call it ABE, is congruent to triangle ADE, and that's side angle side congruence. Now what we want to do is we want to state that this angle is congruent to this, that they're linear pairs, and therefore that these segments are perpendicular. So our first statement is going to be that angle DEA is congruent to angle BEA, and that is CPCTC because those two angles are part of these two congruent triangles. Now we're going to need a little space, and we'll say that they are linear pairs. Angle DEA and angle BEA. So there are linear pairs. That's definition of linear pairs. And finally we can state that AC is perpendicular to BD by the congruent linear pair theorem. So AC is perpendicular to BD, congruent linear pair theorem. And there's our proof. Before we close out the series on quadrilaterals, I'd like to do one final review of all the properties together. So let's go ahead and take a look at them all in one page. At the top of our tree, we have a quadrilateral, a polygon with 4 sides. And on the lower left, the first thing we talked about was parallelograms. A parallelogram is a quadrilateral with 2 pairs of opposite parallel sides. And the properties of parallelograms is both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, and the diagonals bisect each other. Then we looked at rectangles. A rectangle is a parallelogram with 4 congruent angles. And because it's a quadrilateral, the sum of the measures of all the interior angles has to be 360. Since they're all congruent, they must all be 90-degree angles, which are right angles. We have the same properties of all parallelograms. The rectangle inherits from the parallelogram. It inherits diagonals that bisect each other, opposite parallel sides, opposite congruent sides, opposite congruent angles. And in this case, the special property is a rectangle's diagonals are congruent. Then we have rhombi. And a rhombus is a parallelogram with 4 congruent sides. So all 4 sides are congruent. It inherits all the other properties of parallelograms, opposite parallel sides, opposite congruent angles, and the additional property with the diagonals is that rhombi have perpendicular diagonals. In addition, the diagonals bisect both pairs of opposite angles. So this angle is congruent to this to this is congruent to this, and this. Below rectangle and rhombi are squares. A square is a parallelogram that has 4 congruent angles and 4 congruent sides. It's a parallelogram that is both a rectangle and a rhombus. So it inherits all the properties of all these objects. So you have the perpendicular diagonals, diagonals bisecting opposite angles, the opposite parallel sides, opposite congruent sides, opposite congruent angles. All those are true in a square. Then back to the top, we moved over to trapezoids. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. And the direct descendant of a trapezoid is an isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. The additional properties with isosceles trapezoids is that both pairs of base angles are congruent and the diagonals are congruent. Then we moved over to kites. A kite is a quadrilateral with 2 pairs of consecutive congruent sides. So these 2 sides are congruent and these 2 sides are congruent. 2 additional properties of kites. They have 1 pair of opposite congruent angles, and these are the angles that separate or are between the pairs of consecutive congruent sides, and the diagonals are perpendicular. So that wraps up all of our quadrilaterals that we studied in this series. I hope it was instructive, and I also hope to talk to you again in the next series.